On this part of physics, we are going to understand what is the spectrum and what is the ground state, excited state of an atom, and what is absorption spectrum, continuous spectrum, discrete spectrum. And we can understand as well how to find the radius of an energy level of an electron for the hydrogen atom, and also how can we find the energy level of an electron in hydrogen atom, and also we'll understand the difference between electron levels or the levels of energy in an atom. So we understand from the previous video that light is photons, and these photons, they have quantized energy. They have energy, and this energy, it equals H times F, which is constant, Planck's constant times the frequency. And for each color of the light, it has a specific frequency, so that means different energy. Okay, in match with what we have studied in the previous session, in the previous video, here, if we have an atom here, and any atom, as we know, it has levels around it. It has levels around it. These ones are called levels of energy. So here is the nucleus, that protons are neutrons and N, and around it are levels of energy, and these levels of energy are the levels that electrons can be in. Okay, if we are talking about, for example, about hydrogen atom. Hydrogen atom here, it has an electron. That electron is here on the first level. This electron now, when it is in the first level, in its main level, we call this one ground state or ground level. Ground state or what? Ground level. Okay, if light now, if there is a light that comes to this electron, that means light is energy. So if this energy now is given to this electron, it depends on the amount of the energy. This amount of energy, it may take the difference between these two levels. So in this case, the electron will be transferred into higher energy level, to higher energy level. So it's called X. If the energy is higher that is given here, it may be this electron will be transferred into what? Third energy level, or fourth or fifth, or so on. It depends on the energy that is given for this electron. So when the electron transferred from lower, this one here, we call it lower energy. So this one is lower energy, then higher energy level. So when we go further from the nucleus, the energy levels of the atom increases. So now this electron, when it is here now, it is on its ground level. When it goes to this level or to another level higher than it, we call the atom at this state, we call it excited state. So what is excited state then? What is excited states for an atom? What is excited state for an atom? That means when the electron of this atom has moved to higher level of energy. So in this case, we call it excited. These electrons now, to move from lower, as you see, to move from lower energy level to higher energy level, they need energy. They need what? Energy. So that means when they are given energy, they move from lower to what? To higher energy level. And what type of energy is given here? It can be energy of light. It can be energy of a specific wavelength of a color. So this energy now, when it is given to this electron will absorb the energy, of that photon of light, then it will be transferred to higher energy level. And in this case, we say the energy is on the excited, or the atom is in its excited state. Okay, what will happen then? Will the electron remains there? The electron now, when it moves from lower to higher energy level, it absorbed energy to move to higher energy level. Okay, what about this electron? Will it remain rotating on that level, or it will be back to its original place. It can be back to its original, by the way, and it will be back to its original state. And on this case, it will emit what? The energy. That means it will lose energy to go from higher energy level to lower energy level. That means the electron will lose energy, and this energy that it will lose this energy as what? As a spectrum, as what? As light, and this light, then we call it what? A spectrum of emission. So now we understand from here now that electrons, when they are at their ground state, at their normal state around their nucleus, we said that they are at their ground state and the atom itself is in its ground state. When they receive energy from the light, this energy will help them to go to higher energy level. That means to go away or further away from the nucleus to higher energy levels. In this case, they absorb energy. Then when they come back from higher energy level to lower energy level, that means to be then closer to back to their original state, they will lose energy, and this energy that it will be lost, it will be like light. So that means the same light they absorb to go from lower energy level to higher energy level will be the same light they emit when they go from higher energy level to lower energy level. So we understand now that there are energy levels, and if we go away from the nucleus, that means we are moving from lower energy level to higher energy levels. To understand this idea now deeper, look, as we know that light that comes from the sun as white light, it contains all the 7 main colors of light, which are red, orange, yellow, green, blue, indigo, and violet. These colors now are in continuous spectrum. What does that mean? There is no space between them. So that means the color, whether it comes from like a bulb or from the sun, it will be seen like this way exactly. We call this one what? Continuous spectrum. Continuous spectrum. That means as you see, it have gradual colors without what? Distance between them. Okay, this color now, as we said, if we have here an object, and this color now, which is all these colors now, are moving or are shined on this what? Element. What will happen for these elements? As we said, these elements now, they have electrons, and these electrons now, they'll absorb some of the energy of this spectrum, of this light, to go from lower to higher energy levels. So they'll absorb what? Energy. So now when the light is moving through this material now, when it moves, then when it gets out, it will not continue to be continuous spectrum, because some of these wavelengths, some of these colors were absorbed because they are energy. Light is energy. So this energy now, it will be absorbed. When it is absorbed, then this is how the spectrum, then it will be changed. So that means if we put here the source of light and we put here a gas, for example, here called gas, what will happen? This gas now, the atoms of the gas will absorb some wavelengths of the color. So if we take the prism to see, just to see what is left of that spectrum, of that continuous spectrum that it was shined here, we're going to see that the spectrum will be like this. So that means we're going to see lines that are black lines here. These black lines here, they represent the wavelengths that it were absorbed, by what? By the cold gas, in order to increase or for its electrons to go from lower to higher energy level. So you understand now, cold gases or atoms in general that are sensitive to light, when they give them energy from the light, they take this energy, or they absorb some of this energy, quantized energy, not any amount of energy, specific energy. That means specific wavelengths, specific frequencies. So they absorb this energy from the light, then to take it to move, for these electrons to move from lower to higher energy levels. Okay, what will happen then? What will happen then if these electrons moved back? So at this state now, that means the electrons moved from lower to what? To higher energy levels. That means they moved up. Then at this process, they absorbed these colors that are now on black. Where they have missed, they have absorbed by the electrons to go from lower state or lower energy level to higher energy level. Okay, what will happen then if these electrons now move back to their original or ground state? In this case, they lose the energy. They lose energy as what? As light. What light they will emit in this case? They'll emit, as you see, exactly, they'll emit this spectrum. They'll emit these colors that are here, as you see, exactly the same colors they absorbed when they were cold. So that means ground state gases, they absorb energy. And this energy, that means when we say absorb energy, that means they absorb a specific lights, a specific what? Wavelengths of light. These lights then, when they are taken from the continuous spectrum, the spectrum then becomes like this, and we call it what? Absorption spectrum. That means now, this spectrum now is the result of the spectrum after it moves from what? Through the gas. Now, when it's part of it is absorbed by this gas. Then, when the gas electrons move back to their ground state, they'll emit what they absorb. And these emitting now, it will be like these lines exactly, and we call it here what? Emission spectrum. Emission spectrum. If we, as you see, if we put this spectrum now, if we put it on this one, what will happen? If we put them on each other, they'll move. So if we add them together now to make them just one spectrum, they'll move back to what? To be the continuous spectrum as it was. So now what we understand now is cold gases in general, when they absorb electrons, when they absorb photons, that means they absorb what? Energy. When they absorb energy, that means they absorb a special or a specific wavelengths of colors. Then, in order to go from lower energy level to higher energy level. Then, when they move back, they emit these photons, as we call it what? Emission spectrum. So here now, this is now the same idea that happens to electricity. For example, now, this bulb now, how it works at our rooms, in our rooms, at our homes in general, how it gets on, how? What happens exactly, this bulb now in general, this idea to make it easy, here now we have small spring. If you have ever seen it, this spring is inside the lamp. So when the electricity comes from here, when the electricity comes from one side, that means high voltage comes. This high voltage, we understand it's like the energy needs to move the charge from one place to place. So that means it can be dealt as energy. So this energy now, when it is given for this metal, that means it will give it energy for the electrons inside it. So these electrons now, they'll be excited. That means they'll move to higher level energy. Then when they move to lower energy level, they emit light. And this is the light that we use it in general in our homes. So that means they come as a result of what? Of electrons when they come back from higher to lower energy level. And also, if you have ever seen a person who is heating like a steel, if you have ever seen it, like the steel will, while is it heated, its colors or its color it changed. It comes in like blue, red, orange. Where these colors are coming from? They come from because the electrons, when it is heated, the electrons go to higher energy level. Then when they come back to their ground state, to the lower energy levels, they emit the light, which is the same energy they absorbed it from the heat. So they emit this light, or they emit this energy as light. So we see the light based on the energy that is given. So we understand now what is continuous spectrum, and we understand what is emission spectrum, and we understand what is what absorption spectrum. And we need to understand that each element has different emission spectrum. Each element has different. So that means each element now, we can identify elements, one element atom from different element atom by what? By the emission what? Spectrum, or we call it atomic emission spectrum. Because each one, as you see, this one here for this gas, these colors now are the emission colors, you see? So this is the spectrum for one of the elements. Another element will have different what? Emission spectrum. So we can differentiate between the atoms of elements based on their what? Atomic emission spectrum. Okay, based on these ideas, we're going to take example, which is what? Hydrogen atom. We're going to talk about what? Hydrogen atom as what? As example for that. Okay, for hydrogen atom, as we know, we have here a nucleus, and around it there are what? Like here, energy levels, and the electron in general here on the first shell. Now this electron now, if we give it energy, this electron, it may go to this level, or to go what? To this level, or to go to what? To higher level based on the energy that is given. That means now each level, or each level here, it has energy. So if you go now from the nucleus, if you go from the nucleus away or further from the nucleus, the energy, what will happen to it? The energy levels will what? Will increase. So that means this level now, level number 1, level number 2, level number 3, which of these levels has higher energy level? Of course, number 3 will have higher energy level. Okay, how do we know what is the energy level for each of these orbits? How we know them? For hydrogen atom, the energy of each level equals, from this formula, equals 13.6 over the number of level what? Squared. What does that mean? That means we use this formula to get the energy of each level of these ones. Okay, for example, now what is the energy of the first level? The first level, that means n equals 1. N equals 1, and here n equals what? 2, and here n equals what? 3. So n is the number of levels. So that means for the first level, to get the energy of it, you put here n as 1. So that means n squared, that means it's going to be 1 squared 1, so it equals now energy level for the first level here, it's going to be negative what? 13.6 electron what? Electron volt. This is the energy of the first level. Okay, why is it negative? Why is it negative, not positive? Because now when we say the energy of the level, we are comparing it to the electron when it is ejected. Imagine now there is an electron that is ejected from the atom. That means it is at infinity. That means it's far away from the nucleus. In this case, this electron, we call it free electron. We call it free electron because it has no attraction between itself and the nucleus. That means no force of attraction between them. So in this case, this energy of this electron is 0 electron volt. 0 electron volt. So if this energy then, or if this electron here is inside the atom, that means its energy, we give it in negative, because it has this type of energy in order to be free. So that means we give it like, we put it what? In negative, because it's not, when it is bounded to the atom, this energy is negative, because this is the energy needed for the electron to be okay. That means to be free. That means it still need this type of what? Of energy. This is now one of the points that you put it in your mind why it's what? It's negative. Okay. What about now if we are counting the energy for the second level? What will be the energy of the second level of hydrogen atom? And this is now we are talking about what? Hydrogen atom. And this formula is related for only for what? For hydrogen atom. That means for other elements, it may be what different. But what we need and what we have is only what? For hydrogen atom. Okay, for this one now, for the second level now, it's gonna be negative 13.6 over n squared. That means over 2 what? 2 squared. That means 2 squared, that means it's gonna be what? It's gonna be 4. So that means it's gonna be negative 13.6 over what? Over 4. So it's gonna be what? Around negative 3.4 electron volt. Okay, what does that mean? What does this number now here, and what does this number here mean? This number here, it means when the electron at the first energy level, it needs 30.6 of energy, which is electron volt of energy, in order to be ejected or to be away of the atom. Okay, what about now if it is in the second energy level? It needs only now negative 3.4, that means it needs only 3.4 electron volt as energy in order to help this electron to go away of the atom totally. So that means when it is in the first level, it needs 13.6 electron volt of energy to be ejected out of the atom. But when it is in the second level, it needs 3.4. Okay, what about if it is on the fifth level? What about if it is what? For the fifth level? It's gonna be here negative 13.6 over what? 5 squared. 5 over what? Yes. 5 squared, that is what? 25. So it's going to be negative 13.6 over what? 5 squared equals what? 25. Equals 25. Negative 13.6 here, and the choices, if it comes to you, negative 13 over 6, negative 13.6 over 25, it's going to be around half. It's going to be around half or more than half. So that means it's going to be around what? Around 0.54, for example. In this case now, here, that means now if the electron is on the fifth energy level of the hydrogen atom, it needs only 0.54 electron volt in order for this electron to be ejected away of the atom. Okay, now, what we understand now, and we need to understand, as you see, most of the energy needed, or the highest range of energy that is needed by this electron, is to move from the first energy level to the second. Why? As you see, what's the difference here now? If I tell you now what's the difference between the two energies levels, level 1 and level 2 here, what's the difference? You're going to see that energy level, or the difference between energy level between the two levels, it's going to be the final energy minus what? Initial energy. So that means in this case, the difference of energy is going to be final energy, which is what? For the second level, it's going to be negative 3.4 minus what? The first energy level, which is what? Negative 13.6. Here now, what will be then? What will be the answer? If you add it now, if you subtract it, that means it's going to be here negative and negative, it's going to be what? Plus. It's going to be plus, so that means it's going to be around positive 10.2. Around positive 10.2 electron volt. What does this number 10.2 electron volt means? It means the electron needs 10.2 electron volts just to move from the first level to the second level. Okay, what about the amount of energy that this electron needs to be away, to move away from the atom? It needs 13.6. So that means most of the energy will be used just to move from the first level to the second level. And what do we understand from that? What do we understand from that? It's an important note here to understand it. When the electron now is moving away of the atom, or as we go further from the atom, what happens? The difference between the energy levels decreases. Keep it in mind. As we go away from the atom, that means the differences of energy level what? Increases. That means the difference now, as you see, the difference between the first energy level and the second energy level, the difference we found it is what? 10.2 electron volt. Okay, what about now the difference between the second energy level and the third energy level? Will it be still 10 point something? No, it's gonna be less. Why? Because all the energy that this electron needs, it's about 13.6. So that means if 10.2 is just needed from, or the difference between the first one and second level, so that means now the difference between the two and the third will be much less than 10.3. Then if you go between, the difference between the third and the fourth will be much greater. Okay, how do we apply, or how questions comes with respect to what we explained? Here now, this is now is energy level, for example, energy level number 3, and here energy level number 2, and here energy level number what? Number 1. Okay, if an electron moves from here to here, or an electron moves from this point to this point, or an electron moves from this point to this point, here there'll be a change of energy. Here it's gonna be what? A change of energy. And here also change of what? Of energy. And here a change of energy, which is the difference between what? Between the levels. And this energy now is the energy of the photon that the electron, when it moves, it will emit a photon, and this photon will have energy. This emitted photon has energy, and this energy, it represents the difference between the two levels that the electron moved through. So in this case now, which one will be highest energy of the photon? The photon number 1, or photon number 2, or photon number 3? Which one will have? So here now, when this electron moves from this one, it will emit what? As we said, it will emit here a photon. That means it will emit a photon, and here it will emit a photon, and here it will emit what? A photon. This photon that is emitted represents the difference between the two levels of energy. So which of these ones will be the highest energy of photon? Of course, the energy of photon 1 will be the highest, because the difference between the third energy level and first energy level is much more than the other ones. Okay, now which one comes next? Is it photon number 3 or photon number 2? Which one has higher energy? Of course, what? Photon number 3. Why? Because as we go, as here this one means the nucleus. As you go further from the nucleus, the difference between the two levels, the difference of energy between each two levels will decrease. So that means this one will be less than this one. So this one will be higher. So that means energy of the third photon will be greater than what? This energy, which is for the next. So you understand now how to find the energy level of any level of hydrogen atom, and you understand the difference and what happens when you go further from the atom, what happens through the energy levels. The energy levels increases while the difference between each two consecutive levels decreases as we go away from what? From the atom. Last point here we understand, we explain it, is the radius of hydrogen atom, the radius of the levels. So this is now the nucleus, and around it there are what? Levels. I'm talking about hydrogen atom. Okay, on the first level here, the first level, when the electron on the first level here, what is the radius of this circle or of this orbit? If it is in the second, what is this radius? Okay, the radius is given by Bohr formula, that is 5.3 times 10 to the power of negative 11 n squared. This one here, or this formula, we use it to find the radius of electron and any energy level of the hydrogen atom. Okay, here for example, if we are talking about the first energy, that means n equals what? 1. Substitute here by 1, so that means radius of the first energy level is going to be 5.3 times 10 to the power of negative 11 n squared. That means 1 squared is going to be 1 unit, right? Once, and this its unit is what? Is meter. Okay, what about if it is the second here? When n is 2, what will be the radius of the second level? So you put n what? 2, then 2 squared is going to be 4. So the radius of the second is going to be 5.3 times 10 to the power of negative 11 times n squared, which is 2 squared, is going to be what? 4. So in this case, now what we do, we multiply this 4 by this 5.3. 4 times 5 is going to be 20, and 4 times 0.3 is going to be 1.2. So R2 will be 21.2 times 10 to the power of negative what? 11. If you make it scientific notation, so that means you need to move the decimal to one step. It's going to be 2.12 times 10 to the power of negative what? Negative 10. So we understand now, and the unit is what? Is meter. So we use this formula now to find the radius of any energy level of the hydrogen atom. So you understand now how to find the radius of the levels, and you understand the relationship between energy levels, and you understand what is spectrums and what is continuous and imaging spectrum and absorption spectrum, and we understand how light works in general, or how we see luminous objects, and based on what idea they understand, and we understand when energy levels, or when the electron moves to higher energy levels, it absorbs photons, and when it goes from higher to lower, it emits photons. Questions related are in the quiz. Thank you.